My dear students of 9th standard. Nowadays we are discussing about Unit 12 Periodic Classification of Elements. Already in the last class we have discussed about the classification of blocks, S block elements, P block elements, D block elements and F block elements. Now we are going to learn about 12.2.4 and page number of your textbook 143. Advantages of the modern periodic table. It's a very important topic. The table is based on a more fundamental property because mentally prepared the periodic table based on atomic mass, but the atomic number is the basic one for the property and electronic configuration of the elements. So mostly devise the element based on the atomic number. So it is the fundamental property. Second point, it correlates the position of the element with its electronic configuration more clearly. So atomic number, that the number of proton and electrons, plays very important role in the properties and electronic configuration. So it gives the clear position of the element in the periodic table. Then the completion of each period is more logical. In a period when the atomic number increases, the energy shells are gradually filled up until it reaches the noble gas configuration. So each period in the outermost shell, the number of electrons are increased one by one, and finally it reaches the stable noble gas configuration. And this kind of classification is easy to remember and reproduce. Each group is an independent group. There is no subgroups like group A, group B. All these subgroups are discarded in the modern periodic table, and only one position for all the isotope of elements like chlorine, oxygen. So no separate places are given because even isotopes have the same atomic number. The position of the eighth group in mentally periodic table is also justified. All transition elements have been brought into the middle because the properties of the transition elements are intermediate between S block and D block. S block and D block. Then the table completely separates metal from non-metal. Normally the non-metals are present in the upper right side corner of the periodic table. When you see the periodic table, the non-metals are given in the right side, that is carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, helium. All these are non-metals which are given in the right side top of the periodic table. Then the position of certain elements which were earlier misfit interchange in the mentally periodic table now justified because when the elements are arranged in the increasing order of atomic number, the table gives a clear cut idea. Now see, when you're going to take that in the periodic table, when you see that tellurium, iodine, cobalt, nickel. So this cobalt, nickel and tellurium, iodine are a misfit in the mentally periodic table, but now mostly classified, arrange the elements in the increasing order of atomic number. They are in the correct position. Now justification has been offered for placing the lanthanide actinides. Lanthanide actinides are kept at the bottom of the periodic table. Lanthanum 2, lutetium and actinium 2, lawrencium, 14 elements of each categories at the bottom because of this similarity in the periodic table. So these are the important advantages of modern periodic table. Now see, position of hydrogen in the periodic table. Hydrogen is the lightest, smallest and first element of the period because the atomic number also 1, atomic mass also 1. So this hydrogen is always located in the first position in the periodic table. But hydrogen is not a metal, It is a non-metal, but it is given in the group of alkali metal, the first element that is in the group of alkali metal. Now its electronic configuration is 1s1 because the atomic number is 1, only one proton and one electron. So when you're going to write the electronic configuration, the first energy level, the first subshell, only one electron, that is 1s1. Simplest of all the elements, it occupies a unique position in the periodic table. It behaves like alkali metal as well as halogen in its properties. So it's also going to gain electron and lose electron. So it's behave like alkali also, halogen in its properties. Now in table 12.6 is given how to distribute the electron using subshells. So there are a shell, that is a K shell, L shell, M shell, N shell. We have learned already how to distribute the electron using the formula 2n square. Normally we distribute the electron in the primary energy level, that is in the shell, that is K shell, L shell, using the formula 2n square. Now we are furthermore moved in the learning process in depth, that is how to distribute the electron using subshell. So there are 4 subshells already in the previous class you have learned. S subshell, P subshell, D subshell, F subshell. All this you have tried in small letter. So first subshell can have maximum 2 electron. Second subshell can have maximum 8 electron. Then next subshell, that is 18. That is first subshell can have 2 electron. Second subshell can have 6 electron. Third subshell can have 10 electron. Fourth subshell can have 14 electron. S subshell 2, P subshell 6, and D subshell 10, and F subshell 14. This is the maximum number of electrons that can be accommodated. So using this method, we have to distribute the electron. So whatever it may be, the first energy level K shell maximum 2 electron, L energy level 8, M 18, then next is 32, 50, like that. Then the periodic table, it is placed at the top of the alkali metal. Hydrogen is placed at the top of the alkali metal, and hydrogen can lose one electron and going to form hydrogen ion, H plus hydrogen ion, like alkali metal. Also hydrogen gain one electron and behave like a hydride ion, like halogen, H minus, H minus. So alkali metals are solid while hydrogen is a gas. That is the only difference. Then hence the position of hydrogen in the modern periodic table is still under debate, as the properties of hydrogen is unique. Then position of rare gases. So rare gases are in the modern periodic table the last column, last group, 18th group. The 18th group you have learned in the periodic table. When you see in the periodic table, the last group, 18th group, helium, neon, argon, krypton, xenon, radon. These are the rare gases given in the modern periodic table. Rare gases, also called inert gases, also called noble gases. There are 3 different names: helium, neon, argon, krypton, xenon, and radon. Group 18, they are called noble gases, also rare gases, rarely obtained in the universe. So these gases are monoatomic gases. They are not diatomic like a chlorine, hydrogen. They are monoatomic in nature, and they do not react easily with other substance. That's why they are called inactive, inert gases. And their shells are, subshells are completely filled. That's why they are inactive in nature. Hence they are called inert gases. They are found in very, very small quantity. That's why they are called rare gases. So question will be asked, why the noble gases are called rare gases or inert gases? Rare gases because they found in very small quantity. That's why they are called rare gases. Inert gases because they do not react with other substance easily. So they are called inert gases. Then Metals and non-metal. Metals are typically hard, shiny, malleable, can be converted into sheet, fusible, ductile, can be drawn into wire with a good electrical and thermal conductivity except mercury. Most of the metals are solid at room temperature. Metals occupy larger area in the periodic table and categorized. So already we learned the properties of metals. Metals are hard. Metals are having uh, high melting point, high boiling point, and they are malleable, ductile, having the property of sonorous and shining. So these are the uh, uh, general properties of the metals, and they are classified. There is a alkali metal, alkaline earth metal, transition metal, and p block metals. Alkali metals like lithium to francium, that is lithium, sodium, potassium, rubidium, cesium, francium. These are all that is in the first group except hydrogen. They are alkali metals from top to bottom. Then alkaline earth metal, that is from beryllium to radium, beryllium, magnesium, calcium, strontium, barium, and radium. That is in the second group of the modern periodic table. Then transition metals group 3b and 2a. So they are in the in between to S block and D block. Then P block elements, that is aluminium, gallium, indium, thallium, tin, lead, bismuth. They are all P block elements. So they are categorized into four: alkali metal, alkaline earth metal, transition metal, P block metal. Then non-metal. A non-metal is an element that does not have the characters like metal. That is, they're having very low melting point, low boiling point. They are not hard enough compared to metal. They are not having the property of shining, and they are not malleable, ductile. They will not conduct electricity and heat. So, what are the properties the metals having that will not going to bear by the non-metal? So, does not have hardness, shiny, malleable, and not suitable for ductility. In other words, a non-metal is an element that does not have the property of metal. All non-metals are arranged P block. So the P block only having non-metal like a carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, halogen like a fluorine, chlorine, bromine, iodine. Also inert gases in the last column, that helium to radon. Helium to radon. Then metalloids. Elements which have the properties of both metal and non-metal are called metalloid. There are elements which are having uh, in the you're going to see that in the D block, they are having, there is elements like P block elements, P block element, which is the highest variety, having all type of metal, non-metal, metalloid like silicon, germanium, antimony, tellurium, polonium. They are in these like semi-metals or metalloids, boron, arsenic, antimony, all these are. So now so they behave like metal and non-metal also. There is in this periodic table, see that boron, silicon, germanium, arsenic, antimony, tellurium, polonium, they are like semi-metals or metalloids. Now next Alloys. Alloys already learned. Alloys are nothing but it is a homogeneous mixture of metals. When metals are fused together and mixed together to get a homogeneous uniform mixture, that is called alloy. So during 3500 BC, people used an alloy named bronze. The idea of making an alloy was quite old. The majority of the metallic substances used today are alloys. Alloys are mixtures of two or more metals and are formed by mixing molten metal thoroughly. So alloys are mixtures of two or more metal. Rarely, non-metal also nowadays mixed with metal to produce alloys. It is generally found that alloying produces a metallic substance that has more power, useful property than the original pure metal from which it is made. For example, the alloy brass is made from copper and zinc. So, what is the peculiar property of making alloy, and what is the purpose of making alloy? Because that alloying the alloys the new product having entirely different property compared to the original properties of the pure metals. So it's going to be more hard, more strength and durability and the life, everything going to be increased. It will not easily going to distracted by the environmental activities. Then what are the advantages of alloy? Alloys do not get corroded or get corroded to very less extent. So the corroded means it will not easily distracted, will not easily damaged by the chemical reaction when they are going to contact with the carbon dioxide, water and oxygen, will not easily get rust, not easily damaged. Then they are harder and stronger than pure metal. So compared to pure metal, it's going to be hard and strong. For example, gold. Gold is more having more elastic property, so it will not going to be useful for making ornament. So it is mixed with a certain percentage of a copper. It's going to give a hardness, then only it's going to give a design and shape to the gold ornament. They have less conductance than pure metals. Copper is a good conductor of heat electricity, whereas brass and bronze are not good conductor. So copper is one of the important element in making of bronze, brass, but the conductivity of copper is high. But the conductivity of alloys are not high, very less. Then some alloys have a lower melting point than the pure metal. Example, solder is an alloy of lead and tin, which has a lower melting point than each of the metals. So that decrease the melting point. Then when metal is allied with the mercury, it is called amalgam. So mercury is one of the important element for making amalgam. So tin, silver and mercury, tin, silver, mercury, these three are mixed together to get a dental amalgam. It is called a dental amalgam, which is used by the dentist to fill the cavities, the teeth. So amalgam means that is alloy of metal with mercury, alloy of metal with mercury. These are some of the uses and advantages, merits of making alloys. So alloys are very useful. Nowadays, most of the materials are in the form of alloy to increase the durability, to reduce the distraction by the environment. So, advantage is also very important. Now, so my dear students, you have to go through all these topics. There is uh, advantages of modern periodic table, position of hydrogen in the periodic table, and the position of rare gases. What about metal, non-metal, metallite, and alloys? Also advantages of alloys. Now, the textbook evaluation, choose the best answer. If a Doberner is related with the law of triads, then Newland is related with the law of octaves. Modern periodic law states that physical and chemical properties of the elements are periodic functions of atomic number. Modern periodic table, atomic number. Mentally periodic table, atomic mass. Elements in the modern periodic table are arranged in groups and period. How many groups? 18 groups in the modern periodic table and 7 period. Then, in Dauber triads, the atomic weight of the middle element is the average of the atomic mass of the first and third element. Noble gases belong to 18th group, the last column in the modern periodic, that is 18th group. The basis of the classification proposed by Dauber, Newland and Mentally was atomic mass. Dauber, Newland, Mentally all three arrange the element based on atomic mass. Only mostly divides the element based on the atomic number. Example for liquid metal is mercury. Then match the following triads who arrange the elements in the form of 3 by 3 Dauber. Then alkali metal, which is alkali metal, sodium, potassium. So sodium is given sodium. Law of octaves. Octa means 8 element. 8 by 8. Who arrange the element 8 by 8? Newland. Then alkaline earth metal, calcium. Modern periodic table, Henry Moseley. Then true or false? Newland's periodic table is based on atomic masses of elements, and modern periodic table based on atomic number. So it is a correct statement. Newland prepared based on the atomic number, and modern periodic table Newland atomic mass, modern periodic table atomic number. Then next one, metal can gain electron. It is wrong. Metal, only non-metal gain electron. Here it is given metal. So you can write a non-metal in place of metal, or you can write metal can lose electron. So that is a wrong statement. You have to correct it. Metal can lose electron. Then alloys bear the characteristics of both metals and non-metal. That is wrong. Alloys not bear, that is metalloids. Instead of alloys, you have to write metal. It is also wrong statement. Metalloids bear the characteristics of both metals and non-metal. Then lanthanide actinides are kept at the bottom of the periodic table because they resemble each other, but they do not resemble with any other group of elements. This is a true statement. Group 17 elements are named as halogens. That is a correct statement. That is correct, true. Then assertion reason. Statement: element in a group generally possess similar properties, but elements along a period have different properties. Reason: the difference in electronic configuration makes the element differ in their chemical properties along a period. So this statement is true, and reason also explain this statement. Elements in a group generally similar properties, and the difference in electronic configuration make the element differ in chemical properties. Correct statement, that is option E. Then what is answer? The state modern periodic table, that is nothing but the physical and chemical properties of the elements are periodic functions of atomic number. What are groups? That groups and period. Groups are nothing but the vertical columns in the modern periodic table from top to bottom. They are groups. And what are periods? Horizontal rows are called period. What are the limitations of the mentally periodic table? So mentally arranged elements in increasing order of atomic mass, and no place for isotopic elements, and the increased order of atomic mass was not strictly followed. No proper position for hydrogen, and like that. So I will send the answer. You have to write in your classwork. The state 5 modern features of modern periodic table. Now only you learn that is it is increasing order of atomic number, periods and groups, and also physical chemical properties of the elements. They grouped into various families. There are some points are there, so only up to 4 questions are there. So you have to write all this in your classwork. I send the answers I post the answer, you write, and your classwork can get ready. Also prepare the lesson. Don't waste the time. Wish you all the best. Thank you. God bless you.